All right, so this is the video for chapter 3.2, which is on translations of geometric figures. And so let's go ahead and get started. So when you translate something in geometry, it's not like you make it into a different word or anything like that. Translating means that you're going to shift, or probably a better word would be to slide an object or a shape left, right, or both. So when you slide or push an object left, right, or diagonally even, that's what's called translation. Now, how do we actually describe a translation using math? Because again, we can say left and right, but that doesn't really give us a good description because we can move, really far left or really far left or very smallly left. I mean, there's different degrees of left we can move, right? So how do we actually describe that? Well, we use something called a translation vector. And so a vector is kind of like a special type of line or direction describing object that tells you how far left and right to move. And usually it's written like a point, and it's the left-right shift. So this is the left-right shift is the first number, and then the up-down shift is the second number. Or you can say the horizontal is the first number and the vertical is the second number. If your numbers are positive, that means that you're going to move either right if you're the first number, or up if it's the second number. And negative numbers means you're going to move left if you're the first number, or down if you're the second number, right? So for example, if we have, this is my translation vector, this positive 2, remember the first number is left or right, this positive 2 means I'm going to move 2 points to the right on a normal XY graph. And then this negative 4 means I'm going to move 4 points, it should say not to the, but I'm going to move 4 points down, not to the down, but down. Right? And again, notice that this is a vector. This is what these little special parentheses are here, right? This is not 2 comma negative 4 like this. This is the point to negative 4. But if you have these little, arrow markers at the end, that means you're talking about a translation vector, not a normal point on a graph. So let's do a few drill problems real quick, okay? So this is my point, 4 comma 5. Again, I know it's a point because of the curved parentheses, right? I want to translate it using this vector. And again, I know this is my translation vector because it has the pointy brackets. So negative 5 means I'm going to move 5 spots to the left. Well, I don't want to draw a graph and do that, so all that I really do is I simply take this number and I subtract it from my x. So you take the first number and add or subtract it to your x number, which in this case 4 minus 5 would give me negative 1. And then you take your second number, the 3 here, and you add or subtract it to the second number in your point. So 5 plus 3 is 8. Obviously, if it's positive, you add it. If it's negative, you subtract it. And so my new point would be negative 1, 8. That is 5 spots to the left and 3 spots up, right? If I'm 5 and I go 3 spots up, I'm going to be at 8. If I'm 4 and I go 5 spots left, that means I'm going to be at negative 1. Again, we can draw a quick graph to justify that if you want. So, where's 5? So it'd be 1, 2, 3, 4, 5. So here's the point 5. If I move 3 spots up, that'd be 6, 7, 8. So obviously if I move 5 spots up, I'm at 8. So all you do when you translate a point is you take the x vector and you add or subtract it to the x coordinate. You take the y vector and you add or subtract it to the y coordinate. Let's try this one here. Negative 3 is my x vector. So it's negative, which means I'm going to subtract, right? So negative 3. So negative 2 minus 3 is negative 5. Remember, negative 2 minus 3, a negative minus a number is another negative. And 0 minus 7 is going to be negative 7. So that's my new point, negative 5 comma negative 7. And again, logically this can make sense, right? If I'm at 0 and I move down 7, well then I'm going to be at negative 7 on the graph, right? If here is 0 and I move down 7 spots, I'm going to be at negative 7 once I get down there. And then let's try this one here. So 8 comma 1, left and right 0, up and down 8. So you add 0 and you get 8 back. Again, obviously if you don't change anything, you don't change that number. Positive 8 means you're going to move up 8, right? So I'm going to add 8 here. So 1 plus 8 is 9. So again, this is all just addition and subtraction. So over here, negative 5. So I'm going to either, you can think about it as subtracting 5, or you can think about it as adding negative 5, whatever floats your boat there. And then 4, so I'm going to add 4 here. This is going to give me positive 1. 6 plus negative 5, or 6 minus 5, whatever you want to think about it, is positive 1. Negative 3 plus 4 is going to give me also positive 1. So this will be at 1 comma 1. So again, you just simply take your number and then either add or subtract it to the corresponding number in the original point. Now, usually I'm going to have you do this 3 at a time. That's how it usually happens. If you're translating a shape, you usually do this on the corners, right? Like what we did with the reflections. So if you're going to do this on the corners, usually there's 3 or 4 corners to do this on. So you'll get 3 points, and you'll say, okay, translate all 3 of these points using this vector. So this vector right here, -2, 3, for all 3 of these points. Well, you can kind of do this all in one go, right? -2 means for each x you're going to subtract a 2, and then 3 means for each y you're going to add a 3. So your new points would be a prime, which is -7 minus 2 is 5. 3 plus 3 is 6. Remember, you subtract the negatives and you add the positives. And then b prime, -4 plus -2 is -6. 2 plus 3 is 5. And then lastly, c prime here. 1 plus -2 is -1. 1 plus 3 is 4. So these would be my new points, right? So again, you can apply this translation vector to all 3, 4, 5, 10,000 points if you want to, by just simply adding and subtracting the right numbers together. Again, first number, add or subtract to the x. Second number, add or subtract to the y, just like a normal point. Now, if you have a graph, you can obviously do this using the graph to help you out. So some people, again, are more visual like that. So for instance, let's say I give you this shape here, and I say translate the shape using the vector 4, -2. Well, again, if we think about what this means here, 4 means go 4 to the right because it's positive, correct? Remember, first number controls left or right, and since it's positive, we're going to go to the right. And the second number controls up or down, and since it's negative, we're going to move down. So and 2 down. So I could actually write out the coordinates for each point and do this math, or I can just simply use the graph, right? So if I take A here, move 4 right, so 1, 2, 3, 4, and then 2 down, 1, 2. So here is where A prime is going to be. And then I can do the same thing for the other ones. So B, 1, 2, 3, 4 right, 1, 2 down. Here's B prime. And then 1, 2, 3, 4, 1, 2. Here's D prime. And then 1, 2, 3, 4, 1, 2, and here's C prime. And so then this would be my new box, right? So right here, if I connect these points, that would be my new box. Again, sorry, it's a little bit off drawing because I'm drawing with my mouse, but you kind of get the picture, hopefully. So again, if you have a graph, you can actually physically count the jumps yourself. Obviously, if you didn't have a graph and you just had the coordinates like we did in the other ones, like this one here, you don't have a graph to work with, so you actually have to do the math. But if you have a graph, then go ahead and use the graph if you want. Now, one thing you also have to be able to do is work backwards. So you should be able to look at the original points and look at the translated points and figure out what the translation was. So again, here are my original points. You notice because they're not having apostrophe with them. Here are my translated points. Again, the apostrophe means that something's been done to them. So -4, 7 translated to -1, 5, and then 5, 2 translated to 8, 0, and so on and so forth. So my goal here is to figure out what the heck happened. Well, let's look at the first point here. -4, 7 went to -5, or -1, 5. Well, what happened to the x? I went from -4 to -1. Well, if I think about translating deals with addition and subtraction, right? So I'm going to think about it in that realm. What did I add or subtract to -4 to get -1? Well, I add 3. -4 plus 3 is -1. How do I get from 7 to 5? Well, I subtract 2. So 7 minus 2 is 5. So my translation vector would be 3, -2. And to check that, I would check, either the second point or another point. So again, 5, 2. If we translate that to 8, 0, let's see what happens here. So 5 goes to 8, that's plus 3. 2 goes to 0, that's -2. Hey, same translation, right? And if you check this one here, you get the same deal. -1 plus 3 is +2. 4 minus 2 is +2 as well. So it works for every single point. The translation vector should work for all 3 points, essentially. If we check this one down here, 6 to 7. Again, I'll put it right here. So 6, 2 goes to 7, -7. And again, we don't necessarily have to always do the first point. You can always do whichever point is easier to work with. So let me write down all of them here, and then we can see whichever one's easier to work with. So 0, 11 goes to 1, 16. So let's see what happens here. Actually, I think I made a mistake here. This right here. Whoops, nope, sorry. I was right. I thought I made a mistake with the x's when I was looking at this problem here, but I don't think I did. We'll see. So 6 goes to 7, -3 goes to -2, and 0 goes to 1. Well, in each case here, I'm adding 1, right? -6 plus 1 is 7, -3 plus 1 is -2, 0 plus 1 is 1. There's a 1 there, right? So again, that's what it is, right? You can check all 3 points at once if you want to, or again, you can check 1 point and just make sure it works across the other 2 once you get it down. 2 goes to 7, 1 goes to 6, and 11 goes to 16. Well, again, in each case there, it looks like I'm adding 5. 2 plus 5 is 7, 1 plus 5 is 6, 11 plus 5 is 16. So it'd be 1 comma 5. So again, you're just simply asking yourself, what did I do to the x's to get the y's, and what did I do to the y's, or sorry, what did I do to the x's to get the next x's, and what did I do to the y's to get the next y's? So here are your first x's, here are your second x's, and then here are your first y's, and then here are your second y's. So you simply ask yourself, what did I do to go from the first set to the second set by adding or subtracting, and that's how you get your points. And then lastly here, if we have a bunch of translations back to back, instead of doing them each one at a time, we can kind of do this all together. So let's say I have these points right here, right? These are my original points. I want to move them along each vector. So I want to go 4 right, 3 up, and then 6 left, 1 up, and then 3 right, 10 down, and then -2, and then again, I just want to do all 4 of these all 5 of these vectors to each one point. Well, rather than doing this 5 different times for each point, I can simply combine these vectors into one, right? So let's do my x's first. So I went 4, right? And then I went 6, negative, and then 3, -2, 3. So 4 plus -6 plus 3 plus -2 plus another 3. I'm simply adding up all my x vectors. Not the original points, but just the vectors. So let's see here. 4 plus -6 is -2. -2 plus 3 is going to be 1. And then 1 plus -2 is going to be -1. And then -1 plus 3 is going to be +2. So that is my x change in total, is +2. Again, I just got this by adding up all the x spots in my vectors. I don't want to say coordinate because it's not really coordinate, but I added up all the x values in my vectors. And I'm going to do the same thing with the y. So my first y is 3, and then 1, and then -10, and then -1, and then another 3. Right? So again, I'm just adding up all my y vectors, all my y values. Right? So 3 plus 1 is 4, plus -10, whoops, it's going to be -6 plus -1 plus 3 would give me -4 in total. So rather than doing all 5 of these vectors, I can simply do 2 comma -4, and that will give me the endpoint right away. So if you have translations, you don't have to do them all at one after another. You can simply combine all your translations together first, and then apply that single vector to each point there. So I'm going to go a prime here. I'm going to simply add 2 to each x. And then again, the y means I'm going to subtract 4 from each y because it's negative. So a prime would be 6 comma 1. B prime would be 5 comma -6. And C prime would be -2 comma 6. Right? So again, if you have a bunch of different vectors that you're going to translate, combine them all into one big vector first, and then apply that one big vector. Now this only works if you don't have any other transformations. Like if I threw a reflection in right here, if I threw a reflection in there, then I couldn't combine them all in one go. I'd have to like combine these two, and then apply the reflection, and then combine these last 3. So this whole combination thing only works as long as you don't have any other transformations in the mix. Once you have another transformation in the mix, then you have to be a little careful. Speaking of which, let's look at this. So let's say I do a reflection and a translation back to back. Does it matter what order I do them in? Right? If I translate and then reflect, do I get the same thing as if I reflect and then translate? Well, let's see. So I'm going to start with the point 3, 2. I'm going to reflect over the x and then translate using this vector. So here's 3, 2. reflecting over the x. Well, reflecting over the x means, again, you're like folding it across the x-axis, means I'm going to multiply y by -1. So it's going to be x comma -y, right? That's what reflecting over the x means, is multiply your y by -1. So this will be 3 comma -2, right? Now, translate by -1 comma 2. So I'm going to subtract 1 and add 2, right? Subtract 1 from the x, add 2 to the y, and I get 2 comma 0. So that would be my ending point, 2 comma 0. Now, do we get the same thing if we swap these? If I translate first and then reflect, do I still end up at 2 comma 0? Well, let's see. So subtract 1, add 2, translate first, right? So 2 comma 4, and then reflect over the x means, once again, I'm going to multiply the y by -1, leave the x coordinate alone. So 2 comma -4. Well, actually, I end up in a little bit of a different spot here, right? So it actually does matter what order you do stuff in if you're mixing reflections. Again, if you're just doing translation, then it really doesn't matter. Like over here, like I said, it doesn't really matter what order I do these in. I can combine them all together even, and I still get the same result as if I did them back to back. But once you throw in a different type of transformation and you're doing two transformations in one go, then it does matter what order you do them in, so you have to be very careful to do them in the order that you're told. Right? If they give you a certain order, make sure you do it in that order. Otherwise, you might end up with a slightly incorrect answer. So that's it for this video. Hopefully it helped you out. If you do have any questions, comments, or concerns, let me know. Otherwise, hopefully this video helped you out. Have a good day.